Thermodynamics and mechanics were considered to be separate branches until about 1850, when experiments by James Joule and others showed that there was a connection between them. A connection was found between the transfer of energy by heat in thermal processes and the transfer of energy by work in mechanical processes. And so the law of conservation of energy emerged as a universal law of nature. And the first law of thermodynamics is an expression of conservation of energy. The law says that energy cannot be created nor destroyed, only transferred from one form to another. And three main forms of energy are shown in the formula. Delta E is the internal energy of a gas. Q is the heat flow into that gas. W is the work done on the gas. So let's look at a couple examples of energy exchanges. The internal energy can be thought of as the energy that the particles of a gas possess. And let's say that this is a gas that's inside a rigid container, and there's also a top to the container which is movable, called a piston. One way to raise the internal energy of this gas is to actually heat it from below with a flame. That would be an example of heat flow, Q. If heat flows into the gas, then the internal energy of the gas can go up. How else could we increase the internal energy of the gas, though? Well, perhaps we take away the flame, and now we can actually physically push the piston down. If you push the piston down, then you'll be doing work on the gas. Why? Because you're exerting a force and you're having a displacement of the particles. Another way to think about the work being done, though, would be that you're exerting a pressure through the piston and we're seeing a change in volume. So what does it look like? Our particles get compressed into a smaller space. Whereas the piston used to be located here. When the piston moves down, then energy flows in, but this time it's done by work.